All right, so now let's see if we can do a similar thing to find the derivative of the inverse tangent, the arctangent, okay? And I'm going to do it in a similar way as I did the first example, okay? We're going to use the chain rule, and we're going to use the fact that the value of the function evaluated at the inverse is x, okay? So I'm going to start with that, all right? So tangent of the arctangent of x is equal to x, right? I'm taking the function of the inverse, right? So, all right, so now let's differentiate both sides. So d dx of the tangent, of the arctangent of x is equal to the derivative of x, okay? And we're going to use the chain rule just like we did before. Now the derivative of tangent is the secant squared. So we get the secant, hang on a minute, secant, gotta write secant. Secant squared, okay, of the function arctan of x times the derivative of the inside function, which is the arctangent of x. So d dx. Now I don't know what that is, right? But I'm just going to write it as d dx of the arctangent of x. Okay, and then the right-hand side derivative of x is just 1. All right, so now we're going to do something similar. We're just going to solve for the derivative of the arctangent of x. Okay, so what we get is that d dx of the arctangent of x is equal to 1 over secant squared of the arctan of x. Okay. Now that's okay. I want to get rid of this arctan over here. I want to simplify this a bit. So what I'm going to do, I'm going to use the Pythagorean identity to simplify it. All right, so I know that, okay, the Pythagorean identity, there's 3 of them. The one that I always remember is that the sine squared plus the cosine squared of theta is equal to 1. Okay, now the other 2 you can just get by dividing this whole equation either by sine or cosine squared. All right, and I want secant squared. All right, so what I want to do to get secant squared, I need to divide everything by cosine squared because secant is the reciprocal of cosine. All right, so 1 over, if I divide everything by cosine squared of theta, what I'll end up with is tangent squared theta plus 1 equals secant squared theta. Okay, now I like that because, if I take the tangent of the arctangent, I'll get x back, right? So, so let's use this to simplify the derivative here. So we have the derivative, I'm just going to rewrite this, of the arctan of x is equal to 1 over, okay, I'm going to replace secant squared with this relationship, this Pythagorean identity. All right, now you may not have to go through this derivation. You might not remember all 3 of the Pythagorean identities, but I can never remember all 3. I just remember cosine squared, or sine squared plus cosine squared 1. All right, so what I'm going to get is 1 plus tangent squared of the arctangent of x. Okay? And now that allows me to simplify this. Tangent squared of arctangent of x, that's just, so it's just this, tangent of arctangent squared, right? So that's just going to be 1 over 1 plus x squared. Okay? So there you go. There's the derivative of the arctangent. Now add that to your reference sheet, okay? Because this is an important one to remember.